Hello everybody! Today we'll come back to the series about how to use the AI for computer vision, and today we will learn about how to pre-processing data using the TensorFlow Keras pre-processing image. This means the image generator. As you can see in the real life project, for example, we have India, we have the two class, the horse and the human. So in the real life, the data is not be pre-processing. So for training the model, we just need to pre-processing data before to feeding into the AI model. And this is the reason today I will show you about how to pre-processing data for training. So the first, of course, in the first we use in the TensorFlow TF, and from the TensorFlow Keras we use the pre-processing image, and we import the image data generator. So you can see there is a horse or human. So first we create a string. This means the trend folder is for it could be part. Horse or human is the training folder, and we create a valid folder. The valid folder. Copy. And create the trend horse directory is for horse or human horse, and the valid human directory is for validation or human. This is a valid for human folder, and the trend human directory. Horse or human. Oh, so and valid the horse folder, horse directory, valid, the valid horse and the trained horse, valid human and a trained human. So enough. Validation of human horse. So now we do the data processing and we generator is for image generator and we scale to 255 and divided generator is the image generator with a rescale is 1 divided 255 and we generate we have the generated trend data is where the trend generator dot load of the from the directory. So first we have a trend folder. So the trend folder and the target size is for 150 window and the path size is for 128 and plus mode is for the binary because we have it to the plus. So the same as we have the valid data. Valid generator and data valid folder, target site, the bus site, and the last node. So there is a pre-processing data step. And in the next step we do the build a model for the training and we use a layer import. In this tutorial we use the convolutional 2D sequence. That's the flow. Also, they use the model, the sequential model, and use the last modeling 2D, and we flatten layer, and in the last we have the dense layer. And in this tutorial we use the dense dot layer dot optimizer is or MS properly. next step, we build a model, and we use the sequential model, use the model, and now we add the model to the convolutional to with the 16 layer, and the window is 3.3, and with using the activation function reload, and in the input layer we have the 150, 150, and 3 channel image. Okay, now we add to the model and put the max boolean 2D, and we use the window E3.2.2 window for the max boolean, and in the next layer we add the convolutional 2D, and we have the 32 layer and 3.3 window with the activation function is reload, and the max boolean layer is being to use. The convolutional 2D using 64 convolutional neural network 2D with activation function is reload, and the next is the max boolean, and in the next we add the model. We flatten the model, and after flatten we add to dense layer, and in the dense layer we usually using the 500 and 12 where the activation function is reload, and for predict the 2 class we use the undent with 1 and activation function is 6 more. For prediction, and after that we summary the model. Now we check again. So in there is a total param and trainable param. And after the build model, after that we train a model. Generated train data, and we use the generate train data for training, and we using the stack base bow is 8, and the equal is 15, and the variables is 1, and the validation data is for the generated validation data, and the validation step is for 8. Okay, after that is the model save with for example here one is host model dot a file. So sorry, after summary the model we just use the model dot combine for setting the log function and the optimizer, learning rate, and the matrix. So first we set we setting the log function is the binary gross entropy, because we have the two class, so we use the binary gross entropy for measure the accuracy, and in there is using optimizer or MS prop OMS prop function, and OMS prop function. In OMS prop function we have the we have the learning rate or MF also OMS prop function with the learning rate is equal 0.001, and the last one we use the metric is equal the accuracy. So we training the model. For while waiting for the result, we write the predict file. In the predict file, we use the numpy as numpy, and from the TensorFlow dot the keras and preprocessing, we import the image, and we import the matplotlib data plot for show the image, and we import the TensorFlow TF. And in this tutorial, we using Tinker to find analog for logging an image from the internet or from the local file log as open file name. Okay, to that we load the save model. See, we load first we load the save model using the tf dot keras dot model dot using the last model function. And so we finished the training. So we load a human. We load a human horse. We copy the file name. And in the next step, we do the predict process. And the first we using the TensorFlow keras dot pre-processing dot image dot load image with the path. And target size is the equal to target size we input in the model is 150. And first we just need to convert the image to the array. And after that we divide to 255 for matching with the model. And we using the numpy for expand the dimension for the dimension of the s with the s and access 0. Now we assign the numpy better stack for the s. And yeah, we print the image shape for Jack. So as you can see, the S is a image, and the image, and this is the info of the image. And it is after we expand the dimension of S with the after convert the image to the array. After that, we have the data of the image, and in there we we created the model. We use the save model for prediction. And we input the image with the font size is equal 10, and with the plus 0 is bigger than the point. We bring picture is human, and else print picture is off. Yes, that's right. Hmm? Picture human. So so the model is wrong detection. So I don't know why. Now I will train again a model. For in the meantime, I will create the extract layer. And as you can see, the instruction layer And in the instruction layer, we load the image and uh, we use the follow layer in the save model layer to see the output layer. And in the output layer, we visualize the model using the TensorFlow Keras and the visualization of the feature map and the later name there. Okay, retraining. Okay, now we run again. Yes, in this time the model is predict right prediction. So the next we test again. To hear them. Yes, that's right. The model is run okay. So as you can see, in the instruction layer, in there we use the follow in the layer name and feature map, and now we unzip the map, and if the length feature map is equal 4, we will display the grid, and uh, in the range of the feature we display the grid of the feature and display the grid, so to that we show the block. So you can see the feature map. Other model. So in machine learning, in a deep learning, we don't know what the model is learning, but we had a result. The on the hyperparameter and the vector of the model we don't know. So deep learning is a black box algorithm. This is the reason why we don't know about what way the model is learning, and we just receive the output of the model. So thank you for watching.